Hello, everyone, and welcome back. We're making a video today on our electrical system. We'll start with our power generation with our photovoltaic, and we'll move forward all the way through our low voltage and through our 120 volt systems. And we'll do some referencing back to the cargo trailer conversion. So, hope you stick around and enjoy the video. Let's see if we can make this right this time. So we're going to make a Victron multi-plus schematic here for how we're going to wire up a multi-plus inverter charge controller. So we're going to take roughly our size, and this has got some stuff built into it that I'm doing, and we're just going to kind of play through it. Again, I'm using 2x2 squares. Each square is 2 inches by 2 inches, and so it gives us a rough idea of what our scale is. Let's color this blue so that we can make it look a little more Victronish. And I misspelled Victron in there. I'll have to go fix that. Here we're going to start building out a Victron MPPT charge controller, and we'll make it blue as well. And we'll put a Victron servo in here, as well as a touchscreen mount to make all this work together for us, so it'll display all of our information. We'll put a battery bank down here, just a generic battery bank, no particular size, but it's a bank to let us know, that's where our batteries are. We'll put another blue box down here for Victron shunt. This is what's going to tell us our battery usage. Put a black box and a red box for some battery bus bars. Just so much easier to connect cables to a bus instead of to the battery. We're going to put a 2-aught cable between the battery and the shunt, and then again a 2-aught cable between the shunt and the bus bar. We'll pull 2-aught cables between the multi-plus and the bus bar on the power side, and then a 2-aught cable between the bus bar on the power side and the battery. Moving on to the MPP charge controller, we'll pull a 8 or a 10 gauge wire from the MPP charge controller to the bus bar, charging the battery. This way you are charging the battery through the shunt, and the shunt can monitor what kind of power is coming and going. Next, we'll throw in some communication lines between the shunt, and then we'll put a communication line between and the servo, and then we'll put a communication line between the servo and the touchscreen, one in there between the MPP and the charge controller, and then we'll do one between the Victron and the servo. This gives us a good look at what we are trying to build out for just our baseline off-grid electrical. And then obviously we don't show the shore power coming in or the 120 volt coming out of the multi-plus. I think now's as good a time as any to go back to this picture, and this is the control panel in my cargo trailer conversion. And I think if you'll look, you'll see that we've got a main circuit breaker down here, and this is the power coming off the batteries. We've got a circuit breaker here. This is the 12 volt that feeds the aux beam switch box that runs the lights and the fan and everything. This is about 250 or 300 amps, I don't remember exactly, and this one is 60 amps. It'll cover everything we need. Inside this aux beam box, there's fuses for each circuit as well. If we look at the MPP controller here, this is just the MPP controller that I basically laid out a little bit earlier. And if we look, we got two sets of circuit breakers here. And you'll see you've got a set here on the left that is the incoming set. That's coming in from your PV array or from your solar panels. You have a set over here coming in from, that comes from your MPP charge controller, and then coming out of it, it goes down to your bus bars. Now, if you'll look, you'll see a little bit of wire right here and a relay stuck in here, and this is something that I quote-unquote engineered and laid up ahead of time before I really had read a whole lot on the MPP charge controller from Victron. This relay is controlled by this relay, and it is a temperature control relay. There's a temperature probe that runs right down through right there. You can see the wire right there. That is the temperature pickup for this relay, which controls this relay. And the theory was that the temperature control relay would drop out that larger relay and not allow charge voltage from the MPPT to the bus bars to charge the batteries when the temperature dropped below a certain point. Again, as I had built this out, engineered this, however you want to call it, prior to learning what I now know about the Victron Smart Solar MPPT, that function is built into the MPPT charge controller by Victron. So this part right here could be taken out, and we could come just with wire straight from the MPPT to the circuit breakers that feed down to charge the batteries at the bus bars. All right, we're back in Microsoft Excel, and now we're going to lay out some of our 12 volt loads for like our lights and our water pump and a fan. So we'll build a box out here, and this will be our aux beam switch panel. If you revert back to the previous picture, you can see that little black panel from my cargo trailer conversion. And we're going to go ahead and fuse it, or put a circuit breaker on it ahead of time here, so that way I don't mess that up. Then we're going to put some loads out here, and we'll connect each load with some multicolor wire. Now, if we look, we got a green and a yellow going to one load, a brown and a yellow going to a load, and a red and a yellow going to a load. And you say, but wait, Dadio, most ground wires are black. This is correct, but you got to understand that now we're starting to get to a point where there might be a 120 volt wire running close to a 12 volt wire, and 120 volt wires that are black are the line wire or the positive wire. So using something like yellow is kind of a marine standard, and it avoids using a 120 volt line wire in a ground situation on a 12 volt circuit. So we'll also go ahead and drop a box in here for our aux beam touch panel, and a communication line between it and the aux beam switch panel. So that's a solid state relay panel and a soft touch button panel that you mount pretty much wherever you want. We'll go ahead and label our loads in here: a water pump, some lights, and a fan. And mind you, most of the aux beam controllers are anywhere from 4 to 12 loads per controller. I'm only doing 3 here, just being representative of the idea of building this out. Then we'll go ahead and start running an 8 gauge wire from the aux beam switch panel through the circuit breaker and over to the battery bus bar, and we'll do the same thing with the ground in an 8 gauge running over to the battery bus bar. Now we have some of our 12-volt system set up here, and we'll come back in just a second and lay out some of our 120 volt. So now we've built out a system where we're using photovoltaic cells or solar panels to produce electricity, and we're using our multi-plus inverter charger to convert that battery power to 120 volts. And we've laid out our system for our low voltage or our 12 volt. Some people run 24. We got our low voltage side already laid out. So now let's move on and lay out our high voltage or 120 volt AC stuff. Okay, now let's start building out our 120 volt system. And if we look here, we got a gray line coming across to it. It's kind of to denote like an SO cable running from the multi-plus to a circuit box. So we'll go ahead and get it run over, place our circuit box in, and start building off of that. Put some loads out here. Again, we're only going to do 3 loads because we don't need, we're not building out an exact schematic, we're just building out a sample. We'll put our lines in here, and notice we're using a black line, and it looks like a tan. White doesn't show up on this, so I use the tan. We'll label our loads for air conditioner, refrigerator, and an outlet, just basic loads. I'm going to go ahead and drop a circuit breaker in there so everybody can be happy that I got a circuit breaker in. We'll throw a shore power plug in here, and again, like a gray cable to denote an SO cable. And we'll go ahead and plop a solar array in there, and let's do some little altering here and build some of this out a little better. There's our circuit breaker for the PV panel. So PV array is a photovoltaic array or solar panel. It's the same thing. So PV is just photovoltaic. And so now we got kind of a quasi-complete system where we have our sun coming into our PV array, goes through the circuit breaker all the way over to the MPPT charge controller. Then it drops down to the battery bus bars, charges the battery. Then this multi-plus produces 120 volts, so it comes out, goes over to the 120 volt load center, runs your refrigerator and your AC, your outlet, whatever else you've got wired into it. And then also our 12 volt comes off of our bus bars up to our aux beam switch panel, which has the control here, and runs our water pump, our lights, and our fan. Now, if we remember back, we done the video where we saw the Victron stuff on the phone, and that is basically what's going to come up right here on this touch screen. All that Victron information will come up there, and you don't have to connect your phone to it because it's pulling it live out of the servo, and it's right there on that touch screen. Okay, guys, so I hope this has helped you decide maybe how you want to do some of your stuff, or give you an idea of how you're going to set up your stuff. And again, I'm not an electrical engineer. I'm not a journeyman electrician. I just have a knowledge of electricity and a good grasp of it. And this is not a how-to. This is just my DIY and what works for me. So I encourage you to do your own investigation, do your own research, and make sure you build your project right. In the meantime, come back and join us for the next video, and I'm not sure what I've got on tap for the next one, but we'll have another one out in a week or so. Thank you for watching.